Now, today's discussion will revolve around the UML class diagram. And the class diagram also helps us, just like the use case diagram, in representing our software to another individual of choice. So we would utilize a class diagram to represent our software whenever we want to design or develop or build a particular system. So that brings in the question, what is a class diagram? And the class will be very discussive, like we'll be having a lot of discussion. So I'll be calling you at random to ask you random questions as to certain things. So if I call you, don't be afraid. Just tell me what you think. That's all I need from you. What you think. It could be right, it could be wrong. But at the end of the day, it is what you think, and that is all I require of you. So, as I was saying, we are going to look at UML diagrams with respect to a class diagram. And what is a class diagram? A class diagram visually represents the structure of a system by showcasing its classes, attributes, methods, and the relationship between them. It helps everyone involved in the project, like the programmers and designers, understand how the system is organized and how components interact. It also helps to communicate and document the structure of a system. So a class diagram allows us to showcase the classes, the attributes, the methods, and represent the relationship between them. Let's just dive in. What is a class? A class, a class is the name of the class is typically written at the top compartment in the box and it's centered and bold. So that is coming from the diagram of a class diagram. But what is a class? When we say something is a class, what is it? You guys have done Java, right? So what is a class? Let's start with Adams. Adams, what is a class?
Hello, sir.
Yeah, hello. What is a class? Okay, so Adams is not here with us anymore. So, um, Ernest, what is a class?
Hello, sir.
Yes, hello, Mr. Adams, what is a class?
Sir, it's a set of attributes and then methods in this.
Let's say I was 2 years old and you were explaining a class to me. What would you say a class is? Let's
So,
say I was 5 years old and you were explaining to me what a class is. What would you say? Okay, Labi Abina, what is a class?
So please, it's a set of um, attributes and methods which are assigned to a particular object.
Let's say I was 5 years old and you were supposed to explain to me what is a class. What would you say?
I'll say that I might compare it to being in class and then describing the attributes as maybe the subjects that the class partakes in. And then maybe the method to be the things that they're supposed to, maybe homework or something like that. So maybe everyone in that class is supposed to do those sets of subjects and then do those sets of homeworks. That's the
Very,
best way I could describe.
very interesting explanation from Abena. I would give her an 8/10. She seemed
Sir, sir, please, can I come again?
Yes, you can come again, Mr. Adams.
Okay.
What is a class?
Okay, so a class is a set of attribute and then method that describes an object. So I would say uh, a class is just like an entity, or let's take a person for instance. So let's take a student for instance. When we say a student is a class, it means that we have some attributes that like its name and then the class or the program the person is in.
You
And
do,
then the
you do,
method,
you do
the
realize
method.
that in explaining what a class is, you have mentioned class 3 times in the explanation, right?
So, okay, so let's take a student as an object. Object. So we will take the attribute as a name, um, the program the person is offering, and then we will take the method as what the student will do. So student will go to class, they will take part in exams and then assignments. So that's what I will explain as a
Very
class.
interesting class definition from Mr. Adams. Mr. Michael Sapon, what is a class? Mr. Michael Sapon is not with us. Very interesting. Mr. Clifford Ansah, what is a class? Mr. Clifford Ansah is not with us, so I can kick him out of the group. Since he's not here, there is no need to have people here who do not contribute. So let me just kick him out very quickly. Remove. Beautiful. And then we will go to the next person. We have Mr. Kofi Brinton. What is a class?
So can you hear me?
I can hear you.
So a class is it's like a template that describes the
Let me pause
behaviors.
for a second. Pause for a second. All
All right.
those putting in the class group that you have microphone problems, I don't care. I will kick you out because you are an IT student. You knew you were coming to class to do this. Your computer does not have a microphone problem. Your phone does not have a microphone problem when you want to call. But in class, you have a microphone problem. So that one will not fly. Anyway, you can continue.
So can you hear me?
I can hear you perfectly.
A class is a template that defines the properties and behaviors of an object.
So, what is an object? I've asked a very big question there, Mr. Kofi Brinton. What is an
Yes, sir.
object? What is an object? Because the definition you gave me is a marvelous definition. You see, whenever you have IT people and you tell them to give definitions, the definitions they give, sometimes you wonder if they understand the definitions they are giving. Fine. And a class is a blueprint for an object. A class describes an object. A class puts entities and methods together for you to create an object. What is an object?
So an object is something that has its own behaviors and characteristics.
Very interesting behaviors and characteristics. What example can you give of an object, Mr. Lloyd Jr.? Mr. Lloyd Jr. is also not with us, so let's quickly kick him out of the group.
Some the class.
Yes. So, did you just say, can I come again?
I'm sitting in a car. That's why.
Hey, I'm right here. Now, when you say about class the time, so now we need, and now we need. Now we need. So now when you say about class the time,
Yes.
it's when you say about class the time we now work. Let's say that I, the teacher, when I knew it was time for us to have the class, I went to sit in the car and did the class in the car. Do you think I would have shown you respect and be fine with you? Let's move on. Mr. Kwame, Boateng, give me an example of a class, of an object.
Hello, good evening.
Yeah, Mr. Boateng. Hello. Give me an example of an object.
Example of an object. So,
Yes.
for example, let's say a car. So, an example would be like a type of car. So, Toyota Camry.
Mr.
Yeah,
Boateng,
so an example.
Mr. Boateng, I don't know what an object is. Because what
So,
you have just done
example
of an object.
And so I said, so okay. So a class, as an example of a class is like a car, and an example of. Hello.
I'm listening to you. So the example will be a Toyota. That is the object, right?
Yes, please.
I'm starting to understand you now. Very interesting. Very, very interesting. Mr. Ubodopong, read what is on the screen for us.
Hello, sir.
Read what is on the screen for us.
I heard Ubodopong, that's why I was.
Yes, you, Mr. Ubodopong, read what is on the screen.
Say it's Frimpong, please.
Oh, sorry, Frimpong, Mr. Frimpong. I'm so sorry.
Okay, the case study right now. Electric scooter sharing system like Lime, Bed, Tire, but with cool twist. Business overview. Right now it's a dockless electric scooter and e-bike sharing platform operating in a big cities. Users locate nearby vehicles via a mobile app, unlock them by scanning a QR code, ride anywhere and park responsibly at the end. The company also uses users, into brackets, freelance workers to collect, charge, and redeploy scooters at night.
Charlie, who didn't understand what was read right now? If you didn't understand, let me know now. So we all understood. So over here, we have a ride share company. The ride share company shares electric scooters and bikes. So let's say I want to leave my house and come to campus. I'll look for a bike, scan it, ride the bike to campus, and leave it on campus. But I'll park responsibly. Hey, Charlie, very, very nice. In this whole scenario, since nobody raised their voice that they don't understand, what is an object from this image we have read? Who can identify the key objects from this thing which we have read? Let's start with Patrick Coulson. Patrick, can you give us one object?
Hello, sir.
Yes. But please, when I ask you to say something, you don't have to say hello, sir, first. Just say what you want to say. So, Patrick, can you identify an object from this case study?
Okay, so I'll say so can I say juices?
Juices. Okay, no problem. So he has mentioned the word juices. That's okay. So here we have the juices. Okay, so this is number one. That's fine. Number two, Mr. Ernest, can you tell us? Sorry, beside this, please wait. Richmond just raised his hand. Richmond, tell us one. Tell us one.
Sir, please, the users.
The users. Okay. Here, the users is which one? The riders, right? The people who be riding the car. Okay.
Yeah.
So the riders into brackets, the users. They're very good. Now, number three, who also plays a role in this? The two easy ones have gone. So right now, it has become difficult small. Mr. Mark Dixon, can you tell me one?
Yeah, say the QR code.
The QR code.
Yes, sir.
Mr. Magdison, we QR code in count. But we don't know yawa. You fan count. Mr. Magdison say QR code. We don't know yawa. But you better read. Maybe you sure say QR code. Are you there in red? And then Mr. Giovanni Michael.
Hello, sir.
Yeah.
The maintenance team.
The maintenance team.
Yes, sir.
Hey, when you say the maintenance team, what do you mean?
Like the people who would charge the scooter, the electric scooter, and also change.
Okay, Mr. Giovanni.
Yes, sir.
Did you see this part of the case study? This part. The portion on your screen, the portion I just made red. Can you read that one for us?
Okay, sorry. Okay. The company also uses users, freelance workers, to collect the charge and redeploy scooters at night.
And your name maintenance will be.
So please come again.
Is that what is called maintenance?
No, sir.
Because they are supposed to do the things we're saying, recharge them, go and collect them, make sure they are all there. So what do you mean by maintenance?
Hello, sir.
Yes, I'm here. Sorry. So, Mr. Giovanni, what I was saying is that what you are saying is the same thing as the juices. Let me put it in this perspective.
Okay, sir.
It is, and this is not to Mr. Giovanni. This is to all of you. I can identify all the actors in this in a second. So the key point is not me telling you what the actors are. You are software designers, you are software modelers. You should be able to see this case study and in your mind create a picture. It's like you are creating a
Please, we can't hear you.
Sir, please, we can't hear you.
Oh, sorry. Can you hear me now?
Yeah.
I was saying that
Yes, sir.
Yes, sir.
I would know what all of these things are. So me telling you what they are, it doesn't really help you that much. In this world, we have the juicers. Their job is to go around and pick stuff. Make sure all the ones with the low things are picked up and all of those things, they charge them and then they bring it back in the next morning. So every morning people have their rides and things. We have the scooters and the bikes so that people can sit on and move around. We have the admin and the back office so that the admin will manage how things are going, the price, the promotion, the fleet, monitor the health of the battery of the thing. Oh, this place has gone here, go and pick it. This guy is trying to drive the bike to Kumasi. Hey, block him from going to Kumasi. All of those things are done by the admin. We have the city operators. The city operators will go around the city and make sure that they are packed well. They are doing things correctly so that the city will not come and sue us. So we have the city operators. Note that the city team is more like a compliance team, and the juicers are just to go and pick their bike, charge them, bring it back, arrange them well, they look good. So in the world I'm creating, these 5 people make the world come to life. These 5 people make my world come to life. Let's see if you guys can identify the people who make the world come to life. I'm going to drop another case study. Why this class today only one female joined? Only has one, no problem. Wilberforce, read the question on the screen.
Case study. So that Ghanaian smart agri-food processing and delivery platform. Center for a rich cultural relevant UML case study set in Ghana. So the business plan and concept was that the Ghanaian agri-research plus food tech startup business in Tamale and Accra. It connects shareholder farmers who grow millet, sorghum, maize, and cowpea directly to urban consumers and restaurants through a mobile app. How automating the traditional production of Ghana's long season, bounty in South Africa.
Okay, so who can tell me what they want us to do? Now, this question of who can tell me what they want us to do, if you can't read a problem and break it down to a way whereby a simpleton can understand, it means yourself, you don't understand it. Like the ways of learning, there is read and hear and say. Then there is read, hear, and say, and teach. If you can teach something, if you can teach someone something you have read and heard and can say, then you have truly learned and mastered it. So if after reading this thing, he read it to us. Let me read it again. Case study, Chiozafi, Ghanaian smart agri-food processing and delivery platform. Perfect for rich cultural relevance use case systems set in Ghana. business name and concept. Theosophy is a Ghanaian agri-tech and food tech startup based in Tamale and Accra. Because if you do your business and Accra is not part, it won't work. It connects small farmers who grow millet, sorghum, maize, and cowpea directly to the urban consumer through an app. And this makes so much sense because nowadays I'm a bachelor, I'm staying alone, and for me to go through the market and go and buy in toast and things is so annoying to me. I wish there was an app where I can just choose the foods I want, and when I click, they will deliver it to my doorstep, and I don't have to go out and fight. And because I'm a male, the females who are selling the food will cheat me. So I want to choose that. I want to be able to do some nice bampoon, do some nice awuza cocoa, and I can source it from the farmer. That means the small farmer will get money, I'll get my goods at a cheap, and the Theosophy app will be able to charge a delivery fee and also make some money. Who are the key factors who play a role in this environment? We have the small farmer. We have the village level agent. We have the Theosophy processing hub. We have the delivery driver. We have the urban customer. We have the restaurant. We have the cooperative administrator. We have the quality inspector. And we have the mobile money payment gateway because people will have to pay. And you can realize that the mobile money payment gateway is an actor because the gateway allows you to process the payments. It's not you who's going to do it. So the gateway owner must have this involved. You must be able to identify who plays a role in your environment. Now, to you, as the IT person, the person who plays a role to your environment is the entity. So over here, you have the entity. You have the entity. It's simple enough. And if you have an entity, all you need is the entity's attribute. So if I say that for the Theosophy app, my entity is going to be the farmer, then the attributes are obviously going to be the person's ID, the person's name, the person's age, that date of birth, the farm that the person is farming. One second. The farm that the person is farming. I want to know DOB. Over here, I want to know the person's land acre or land size. I want to know the person's farm goods. So on and so forth. Now, if I take all of that information that I have just made for my entity, so over here, I come and I say my entity is going to be a farmer. I come here and I say my entity is going to have all of these things. So it's going to have an ID. My entity is going to have a name. My entity is going to have a name. My entity is going to have, let me put this one here. Oh, I did this one for this. Let me stretch this one out a bit. A second. I need the other square. Perfect. Oh, okay. So I can't. Okay, let me use the side. I want to stretch it. 1 second. Sorry. I want to just do it. I just want to do, how much did I do here? 1, 2, 3, 4. So I just need 2 more. I don't need this one. So you can go on. Then here, I want to add 1 more here, 1 more here, 1 more here. Perfect. Let me bring it back to the top. So here will be ID, here will be name, here would be DOB. Over here would be the person's farm. So I know what he is farming. And over here, I want to know the person's land size so that I can know what the person is farming on. And then over here, I don't need this one. Then here, I'll put in the things the person can do. He can receive payments. So let's say he can receive payments. Over here, I can say that the person can also, let me go back. Let me put this in here. Copy, copy, copy. Perfect. So over here, the person can, let me remove this receive payment thing. Perfect. Over here, the person can receive payment. The person can log his goods on the marketplace, and the person can cash out. To the database administrator is focused on this one, the entity. To you, the programmer, you are focused on this one, the class. The class diagram adds the actions. What are you going to do? That's why every time in which you explain a class, you say the class has the attributes. What makes the thing the thing? If you are a farmer, you must have an ID, you must have a name, you must have a date of birth, you must have farm goods, you must have a land size. If you don't have these things, then you cannot be a farmer in our organization. But over here, you must be able to make payments. You must be able to receive payments. You must be able to cash out. You must be able to log that my farm has these goods and these goods are ready for pickup. If you can't do this, then you are not a farmer in my organization. But for the database administrator, he just wants to save your data, so he doesn't need the action. So you being able to identify the entities that play a role in your environment is very important, because the attributes will form your database, and the attributes and their actions will form the classes. And it is the classes that you would use to code whatever system you want to code. Whatever you want to build, it is that in which you use to build it. And why do we call this a class? Because this defines how an object will behave in my environment. If you are a student in a school, if I call you and say, oh, you are a student in my school, You are a student in my school. And I say, you are a student in my dancing school. And I go and say, you are a student in my KG. All of these three boxes here are there for student. 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 You are a university student. You are a JSS primary school student. You are a dancing school student. All of these three students here are not the same. Even if I say that here you are a GCTU student, or a Blue Crest student, or a UPSA student, here if I say you are a Garrison student, or a Kotoka student, or you are from services, here if I say you are learning salsa, or Afro dance music, even that alone changes what information I will take about the student. So when we are defining a person who will exist in our system, the attributes are important because they tell you the things the person can do and can be saved, and the information that can be saved of the person. That means that there are certain information that cannot be saved of the person, and that's okay. That means that in our environment, we don't care about that information. We don't care. For example, over here, when you're a student in the primary school, we care a lot about who your parents is because the contract is between you and your parents. It's not between you and the student. The student has a parent, and the parent is the one who is contracted to the student. That's why when you do something bad, they call your parent. In university, when you do something bad, they don't call your parent, they call you because the contract is with you. So even the information we take, we don't say parent information, we just say next of kin. So if something happens to them, you have to call someone. Who do we call? But in the primary school environment, we take parent information because if something happens, we are calling the parent. Does that make sense, ladies and gentlemen? With that, it means that I should be able to give my attributes and my class, my methods. And together, they form a blueprint so that if I give them values, then I've created one person, hence I've created an instance. That's why you see in some definitions, they'll say an object is an instance of a class. That means if I take name, Kwame, this, that, and I combine it, I've created one student or one farmer or one individual. So I've created one of them. I've created an instance of them. In UML diagrams, we draw a lot of class diagrams. And one of the diagrams we will draw for a class diagram would be this. This is what we call a class diagram. So the first box would be the name, the entity name. So in this case, it is car. The attributes of the car are make, model, and year. And in colon, you have the data type of them. Make is a string, model is a string, year is an integer. Then over here, the actions that the car can do. The car can start, the car can stop, and the car can drive, and the drive is taking a parameter of data type integer. The modifiers behind it show the notification. So over here, I have the visibility notifications. If it is a plus, then it's a minus, and we have a curly bracket to show protected. So if it is a plus, then it means that everybody can have access to it. If it is a minus, then it means that it is private. And if it is a curly bracket or a hash, then it means that it is protected. So in here, I have the name, the attributes, and the operations. And this is the structure of how our class diagram should be. So I'll have the name, the attributes, and whatever methods I want to define for my class. Again, the visibility is important because it is the visibility that we will use to show encapsulation and the characteristics of object-oriented programming. So over here, by visibility is given by this. So if it is plus, then it is visible by other classes. If it is minus, then it is only visible by one class. If it is hash, then it is visible by that class and its children. And if it is a wiggly minus, then it is a package which is by default only visible by other classes in that package. So just for layman terms, it means there is a folder. Anything that is in that folder can be seen by it. If you are out of the folder, you can't be seen. That is the last point. At this stage, are there any questions? Class diagrams present you with this. You have your directions. You have your composite, directional. You have your composition, directed association, usage, that is dependency, generalization, aggregation, association, dependency, and realization. All the arrows you draw are not the same. So this is how I will show a relationship with a class diagram. Let's look at them all. If I say association, then it is a bi-directional relationship between two classes. It means that each of the class has a relationship with the other. So sorry, it means that how will I say? Let's say me and the course. I have a relationship between the course, so that is an association. So the relationship is for me to the one course. I am a teacher. I am assigned a course to teach. So that is our relationship. We have a directed association where two classes has a direction indicated that shows that one class is associated in a specific way. So if it is directed, then it means that it is showing carefully that, oh, from this class we go to this person, from that person we go to this person. The arrow can't go back. We know the direction in which the arrow is supposed to go. But if it's only association, then it goes in both ways. It means that there is a relationship between the two. By a directed one, only one way. There are some times whereby in a relationship, I am related to you, but not fully. I have a relationship with you, but only in certain circumstances. So it's not fully a relationship. And if I want to show that there is a relationship, but it is not fully, it's only in certain circumstances, then I would use the aggregation to show that. If the relationship is strong, if the relationship, if you are not there, I don't exist. I can't be there alone. I need you for me to exist. Then I will use a composition. So if I'm using aggregation, it means I need you, but I don't really need you. To be honest, if you wanted to, I need you, but I don't really need you, then I'll send the aggregation. But if you're not there, I will die. If you're not there, I can't live. Then I will show composition. I use realization when I'm using an interface. That is a discussion on its own. When there is a loosely coupled relationship, we use dependency. So when the relationship is loosely coupled, we use dependency. That is, the relationship relies on the other, but it is not as strong as association or inheritance. I would use dependency as my relationship. What is the purpose of a class diagram? Why will I draw a class diagram? Why will I draw a class diagram? The purpose of a class diagram is that it is the only UML that can properly depict various aspects of object-oriented programs. Proper design and analysis of applications can be faster and efficient. It is the base for deployment and component diagrams. That means that if I don't do a class diagram, doing a deployment and a component diagram becomes very difficult for me. It incorporates forward and reverse engineering. What are the benefits of me using a class diagram? Class diagrams represent the system's classes, attributes, methods, relationships, and provides a clear view of its architecture. It shows various relationships between classes, such as association and inheritance, and helps stakeholders understand the components' connectivity. Class diagrams serve as a visual tool for communication among team members, stakeholders, and bridging gaps between the technical and the non-technical. They guide programmers in coding by illustrating the design, ensuring consistency between the design and the actual implementation. And many developmental tools allow for code generalization from class diagrams, reducing manual errors and saving time. Because if you put a class diagram in an AI bot, it just does a good job of understanding everything in which we want to do, because the structure is there, the database is there, how the thing will work is there, the models you do are there, the functionality of the system are there, everything is there. So a class diagram is just a breath of fresh air. Today we had to discuss the class diagram. Next week, we will combine the use case diagram and the class diagram by taking numerous studies, read them, analyze them, and draw the diagrams. We will draw them, physically draw them, and see how we can make our diagrams better, worse, which approach should we take, and in doing so, model our system from scratch. Thank you all for coming today. We'll meet again next week.
Thank you, sir.
Thank you, sir.